All right, here we go. A little bit about me, or my cousin. So I used to speak a lot, because I used to be in a startup, and when you're in a startup, you actually want people to know what you're doing. And then I went to this company, I can't remember the name of it, because, oh, I know, I saw it in the airport this morning, Oracle. And when you're a big company, you don't want people to know what you're doing, because that would only confuse them. And you don't want to confuse the buyer. You want to make things simple, right? So you tell them things like, oh, we're the top 10 in top 10 signs, or the, nothing? We're the top 10 in number 1 in airport advertising. A little better, a little better. All right, so it's no kidding, it's been 3 years since I spoke at a non-Oracle event, which is, that's like long enough for Java to die like 12 times. Like Swift is going to kill it, no, Python's going to kill it again. Let's see. I used to do a lot of speaking, and so the easiest way to come up with something was, to write down everything you know. But the problem is, if I told you what I knew, like you'd ignore it, and that's the problem. When you give a presentation, you got to kind of sneak the message in, right? Because if you come out and you say it, and like, this is my message, I want you to learn something, people are like, like nobody wants to listen to a message because you guys know everything, right? Anybody here not know everything? 1, 2, okay, wrong industry. Like if you don't feel like you know everything, you shouldn't be working with computers and, like my kids know everything. It's like I turn on the computer, Dad, doing it wrong. So I used to make these top 10 lists, and I used to kind of invert them and be like, the top 10 ways to really screw up your application. And the funny thing is people would actually learn from that. I'm going to invert it today back to normal just because I'm lazy. But I used to make fun of things like C++. Anyone here ever use C++? Man, I'm sorry. Me too. I still use it some, but supposedly it's getting better. And I used to have hair. I'm doing the Rod Johnson. And it wasn't all going gray. And yeah, I'm becoming a very sad old man. And well, that's all I got. All right, so, I have to apologize. I got to start by apologizing because a couple months ago, or years, I'm not sure when, like Geeta calls me up and she's like, I want you to come and speak at GOTO Chicago. It'll be great. And I'm like, I haven't spoken in public in a while, and I don't have any presentations. She said, oh, no problem. I'll just make up a title and put it in the, all right, okay, it should be fine. We always enjoy it, right? We have a good time. And so she put the future of Java. So guess who in this room is not responsible for the future of Java, but is on stage? Okay, anybody? All right, so I started, coming up with some like alternative presentations I was going to do. So instead of, the problem with the future of Java is like, I already did that presentation back in 2011, right, at the Java Language Summit. So if you want to see me talk about the future of Java, which, you still haven't finished yet, I put the list together of what we needed in Java. It's all there. You can write down the URL. The problem is, if I talk about the future, I got to put a legal disclaimer on my slides, and it sucks. It like ruins the whole deck. And I thought George was actually going to be speaking at the conference and talking about the future of Java, but I did see Attila here and others, so I'm sure you're going to get lots. Actually, I'll mention a little bit on what I think about the future of Java later on in the presentation. So, I was like thinking, okay, what would I present on? So it's like last night, and I'm sitting there, thinking, okay, I've got a couple hours before I fly out. I've got to, put together a presentation. What am I going to talk about? And so, I started working on titles. So my first one was the top 10 presentations I ever did present. That didn't go over so well. How about whoa, where'd that come from? Anyway, we'll skip that. Let's see. This one should speak for itself. As you can tell, I don't do as much programming anymore because I'm now a pointy-haired boss, so I mostly do golfing. What else do I do? Sailing, golfing, schmoozing, mostly schmoozing, and in PowerPoint. And Excel, I'm really good at Excel. So if you ever need help with Excel, like I can show you how to sort a column or sum it up. Oh, and I settled on this, the top 10 stories from my list. Are you watching? It's like PowerPoint magic. Check this out, watch. Look at that. And I swear to God, I figured out how to do all this last night. Because anyone here ever build and deliver a presentation? Come on, let's see some hands. Right? Isn't it amazing? You spend 4 minutes putting the content together, and 6 hours, 1 pixel over, and yeah. So I'm going to start with number 10. And I've told this story a few times, but I bought this book years ago, and it was called The 7 Habits of Highly Effective People, I think, because I wanted to be one of them. And so I opened the book, and the first chapter is called Begin with the End in Mind. I was like, oh, that's a great idea. Think about where you're going, begin with the end in mind. And then I started reading. I was like, man, this book sucks. And I never finished chapter 1. But it did remind me of this story of a father and his son, a young son, I don't know, maybe 5 years old. And they're outside on a snowy day. And they're standing there in the yard. And the son is trying to beat his father at one competition or another. And he says to his dad, I bet I could walk in a straighter line than you. And the dad says, okay, see that tree over there? Go walk to that tree. And let's see who can walk in a straighter line. And the little boy, he starts walking, and he starts, he's very carefully balancing. He's putting one foot in front of the other. And he turns around, and his dad's still standing there, and he's like, okay. And he finally gets over to that tree, and he turns around, and he looks back, and his path is all like S's, right? Because he's been watching his feet and trying to make every step perfect, and that instead of thinking where he's going. And the dad, just walks over him, looking at the tree and taking the longest steps he can, and of course, not every step was perfect, but the line itself was close to perfect. And it's one of those, heart-rending stories, but the concept is actually really good. It's sometimes we get so stuck in the details, we forget about, you like that number 10, begin with the end in mind? That was number 10. That's the first one, begin. Oh, God. Man. Tough crowd. Tough crowd. So, there are a couple different, obviously you can apply this to technical things. If you're looking, for example, at some of the work going on in Java 9, a lot of the writing that goes into the concepts of what's coming, it's arguments about, and I don't mean arguments in the, he said, she said, or I'm right, you're wrong, not that kind of argument. More like a legal argument, like a weighty thought about how can we make decisions that we won't look back on and feel were the wrong decisions, like generics. Sorry, generics. How can we make decisions that are good? But I think as well, I unfortunately got into management, so I don't get to make technical decisions anymore. But I see the same thing, in terms of managing, whether it's managing technical people or others, having a concept of where you're trying to end up, whether it's a technical goal or whether it's, whether it's a moral goal in a sense, right? So what are the things that you're trying to accomplish? Think about, make your decisions based on that. I wanted to give an example of this, and from my own personal history. So in 2006, we had a company approach us. We were still in a startup, and this company approached us, offering to buy the company, our startup. And we had gotten lots of offers over the years, but this was the first time we got an offer that was actually big enough that we didn't laugh at it. Now, it wasn't the right number, but the problem is when you have shareholders, you have to represent the interests of your shareholders. It's what you call a fiduciary responsibility. In fact, I've been using the word fiduciary a lot lately. Sorry, inside joke. Slip out the back, Jack. When you have a fiduciary responsibility, you have to take into account the decisions that others would make if they had access to that same information, because you're responsible for making decisions potentially on their behalf. And so we sat down as a board, and we walked through it very carefully. We said, okay, let's forget this particular offer. Let's forget all those things. Let's start by asking the question, what is it we would want to accomplish in an acquisition? What would the goals be? What are the things that, and we laid them out and we prioritized them item by item. And you have to understand, I'm the world's least organized person, if you couldn't tell by the fact that I was writing a presentation at midnight last night. So to take that time to do it, the gift it gave back was really simple. As we went through the process of the acquisition, every time we had to make a decision, we just looked at the list. I mean, the list, we didn't have to look at a whiteboard or something. I mean, it was in the head, right? But we'd say, okay, does it meet or defeat this goal? Does it meet? And we just went through it. And basically, every decision ended up pretty much making itself through the process. And one of the interesting things out of it was that in the end, we chose a company out of the number of companies that were bidding on our startup. We chose a company that was far from the highest bidder in that process, because we had made the decisions not based on just random, like, what's the amount of money or whatever. We had made those decisions based on those priorities, and it made it very easy not just to make the decisions, but then to look back and explain why we had made them. Number 9, manage to your pain. Has anyone ever heard anything like this, manage to your pain? This is probably the only brilliant management thing I ever came up with. So when we were a startup, I'll compare and contrast being a small startup and being a large bureaucratic organization. We had a support system, right? So if someone bought our software, they could call up for support. Makes sense, right? We had a fully automated system, so they'd call up, press 1 if you don't want to speak to a human. Press 2 if you'd like to hear this menu again. Press 3 if you want to hear something other. No, I'm kidding. We had a nice, so basically they'd call up, they'd leave a number, and they would get a call back within 30 minutes. That was our support policy. They would get a call back from someone who was an engineer, not from someone who was not an engineer. But our support policy was really simple. We'd give a customer a piece of paper, and it said, okay, these are the 3 numbers. 1 is the toll-free number that gets, that you leave your message on. The second number on the list was the cell phone of the COO of the company. So if you didn't get a call back in 30 minutes, the next person you were calling, maybe waking up out of bed, was the guy in charge of the entire support process, personnel, etc. And the third number is the number that's in the phone I put in my bag, but it was my cell phone number. So why would you do that? And the answer is you want to manage to your pain, right? You want to say, if something goes wrong, it needs to hurt. Who does it need to hurt, right? In a big company, who does it need to hurt? In a big company, you want to hurt the person you pay the least, right? You want to pick someone half a world away. Am I touching some sore spots? Think about it, though. Like, compare the DMV, with a neighborhood cafe or something, where the owner is there serving you and trying to win your business, right? Think about the faceless bureaucracy versus that personal level of service. Manage to your pain says, if something goes wrong, make it hurt, and make it hurt the person who can fix it. So, in 8 years of business, I got 0 calls. We had lots of support calls, by the way. Not because there was anything wrong with our software. It was perfect, I'm sure. But because we managed to the pain. If something went wrong, it was caught by someone who could fix it. Number 8, finally get to talk about something technical. Random is awesome, or stochastic is fantastic. That's pretty good, right, Gil? You like that? So what do I mean by this? Gil, you probably know where I'm headed. This is one of the things I wish I could turn this into a project. So if there's anyone out there that thinks, oh, this is a cool idea, stick this in JUnit, please. So it turns out that testing is very difficult, right? You've seen the unit tests, right? You write them as new class. Well, that worked. Next unit test. New class dot add x, right? And so on. And it's like you have 53 unit tests. They all test like one little thing, and you're done. Then you ship it, and it breaks because it didn't work. If you were listening to Martin this morning, you heard about all the concurrent stuff, for example, things like that. So, as I was trying to figure out how could we solve certain classes of problems that we were seeing in terms of data structures and things like that, came up with this idea. Not that it's original. I mean, there's fuzzing and things like that. But what we did is we created DSLs for specific things that we were testing. And when I say DSL, what does DSL mean? It means I made up some strings, and each one of them had a meaning. That's all a DSL is. It sells books, but it's a lot simpler. So basically, if you think of this, let's see, is there a pointer? Yeah, so this thing on the left. So basically, for every function that we wanted to test, yeah, sure, we had some static unit test for it, but we'd create an operator or a verb in the DSL for that operation, for that function point. Or sometimes it's a more complex set of function points that go together. And then we would randomize creation of a test. And the way the test would get created is we'd create a control case. So for every data structure we were testing, we'd either reuse something that was existing but safe, or we'd create a control case that was allowed to be simple but inefficient. And then as we created the test, we would actually apply each random operation against the control case so that we had a state, an expected state, for every step of the test. And so the operations themselves are not truly random. They would either be purposely correct operations to test some operation that should succeed, or purposely incorrect operations to test something that should fail. And so it would create, if you will, a list of operations. And this is a fully randomized test. And then we would run the test. And when we ran the test, we'd create a new control data structure. We'd create the subject of the test itself. We'd execute the list of steps in the test. And any time after each step, by the way, it would do a comparison, both of the result. So it would compare the return codes, for example. It would compare exceptions, if any. It would compare, what else? The state of the object itself, right? So basically, each one of these operations was being compared between a control case and the data structure being tested. And then when it found a failure, it would actually go through and ask each one of the verbs to print themselves out. And it would, here, let me actually show you. Although I don't know where they found these EGA projectors, so if this doesn't work, don't be surprised. Let's see, come on. I have it up here, yeah, wow. Does anyone know what EGA is, or am I just really that freaking old? Damn it. CGA, no, yeah, so here we go. So this was an example of one of the tests I wrote. And you can see, it's chugging along, hits an assertion error, something didn't match, right? So it prints out the one versus the other, and then it shows me the test code to reproduce it. So I think we were talking on this one last year. So I had written this new data structure, not this one, a different. I had a Christmas break, so that's the only time I get to code is when I'm on vacation. And I wrote, the typical 53 unit tests for it. And then with this approach, I proceeded to write another 15 billion tests, but only kept the ones that failed because each one of them became a regression test. So like if, for example, come on, mouse. I know how to use a computer, don't worry. But if I don't, I'm sure there's someone who can help me here. All right, let's do this. What do I have? How do you do that? Is there such a thing? Are you just messing with me? View. Where is that? Enter presentation mode. Dude, that's so cool. I'm in the wrong one. Hang on, wrong tab. Do I know what I'm doing? Nope, not that one. All right. Let's go back out of this so I can get to the right tab. Thank you, that's perfect. Let's see. Nope, not that one. What happened to my other tabs? This? Crap. All right, now I'm looking stupid. All right, let's try this again. Where'd you go? IDEA was not meant for this, by the way, because it's no longer appearing on my screen. Okay, code examples are going to be slightly difficult. Not this one. How do you exit the full screen? All right, somebody tell me the keystroke on Mac for getting out of the full screen thing. Control Command F. Thank you. For some reason, it seems to have closed all my tabs. Okay, look at this one. So where was I before I was so embarrassed? I was talking tests, wasn't I? Oh, yes. So these are examples of some of those tests I was describing. So basically, every time it would hit an assertion failure or something went wrong in the test, prints out the source code. You take the source code, you slap it into your test. You have a new unit test. Use that as a regression test. So now you can debug it. So apparently, I had 42 bugs that I found using this. It's a good number, right? It's like, yeah, 10101. No, got that wrong. 10. Anyway, close. All right, let's go back to the presentation. Obviously, I'm more comfortable in PowerPoint. I can change my mind about having that recording posted, right? So, let's go forward. So, randomized tests, certainly one of my favorite things of late. Never give in. So there's a common misconception that Churchill gave this speech called "Never Give Up," but it turns out it's "Never Give In." And it's interesting. Has anyone actually read that speech? Anybody? Just a couple little hands. Nobody stood up and said, "Yeah." So it's a long speech, but I'm going to read the whole thing. Just kidding. Now, actually, the beautiful thing about this speech, and I'd encourage you to read it, by the way, search for "Never Give In," Churchill. There's a beautiful part of it that the first 50 times I read it, I never noticed. But if going back, it strikes me, Churchill, his entire life was a failure, except for one little short period of time called World War II. Basically, everything he did before World War II was a complete and utter failure. In fact, the worst battle, the worst losses for the English in World War I was Churchill making some gut decision to attack an impossible position to attack and so on. There's some cliffs somewhere in the Mediterranean or something. He was just a completely horrible tactician, strategery. But in World War II, he somehow found that vein, if you will. And what I loved about the speech, this was a speech he gave at the school he went to as a child. And he went to visit them. And they had added a verse to the school song in honor of Churchill. But what I thought was amazing is this actually happened during the war, when things looked pretty bleak. And the amazing thing that he did in this speech is as follows. I just want to read one paragraph. The 10 months that have passed have seen very terrible catastrophic events in the world, ups and downs, misfortunes. By misfortunes, he means the Battle of Britain, London basically being razed by bombs dropping on it. He says, but can anyone sitting here this afternoon, this October afternoon, and not feel deeply thankful for what has happened in the time that has passed and for the very great improvement in the position of our country and our home? So he took what for most people would have been like the depths of despair, and he turned it around and he said, don't you see those things that we have to be thankful for? And he said, one of the best lines that's up on the screen, he said, we have only to persevere to conquer. In other words, here was someone who saw beyond kind of the current situation, the current despair, the current travesty. He saw over that hill, to something beyond it. And he said, all we have to do is keep going, and we'll get there. Like, I can see the light at the end of the tunnel. And I love when I build a presentation. And I usually take much more time. It usually takes me over an hour a slide, which is why these are so crappy. I apologize for the quality of the text, but I could only draw so many pixels. And normally I like to put pictures on and stuff like that. But the story I wanted to tell, and when I build a presentation, it's all about a story. The slides are just there to kind of give you something to look at while I talk. But I have this beautiful story. When I first was at Oracle, we were this tiny little company coming into this giant behemoth. And I remember, we wanted to get Oracle Consulting to work with us, right? You would think, being at Oracle, having been purchased by Oracle, that, they'd send someone from consulting to talk to us and be like, yeah, we want to be able to do consulting on your software, right? Right? Yeah? Nobody's nodding, except nodding off. Okay, so nobody came to us, right? So we had to go search them out. Obviously, they weren't managing to their pain, right? So we had to go search them out and beg them to do this. And they're like, okay, fine. We've got one guy who nobody wants to hire. You can talk to him, right? Here's a consultant. Talk to him. We're like, well, okay, it's better than nothing. One is better than nothing. So. This guy was a fairly junior consultant. We could tell he had a lot of passion, a lot of eagerness to learn. We're like, yeah, we can work with this. And he started learning, and he's like, oh, this is fun. He started learning and learning. And then we get an email saying, yeah, I really love this product. I love working on it. So I've written some code for you guys that I want you to put into the product. George is smiling because George is thinking, oh, this sounds so familiar, managing Java. And so we're like, oh, that's great. And we go and we look at the code and we're like, oh, that's not so great. Okay, we're going to draw straws to pick who's going to go tell this guy that, thanks, but, maybe McDonald's is hiring. This is, yeah. So I'm exaggerating a little bit in terms of, we didn't say McDonald's, we're talking Dunkin' Donuts, but we're in Boston. Come on, Boston. So one of our architects went and talked to him and said, look, really appreciate what you're doing, but your code does not meet our standard. And I'm not talking coding standard, I'm talking about, the bar. It doesn't meet it, from a design point of view. It doesn't meet it from a quality point of view. It's not coming in. And that's a pretty hurtful thing to tell someone, right? Because everyone thinks their code's better than everyone else's, right? So finding out that it's not is pretty crushing for a programmer. Anyway, didn't hear from him. I think he went off, and who knows what happened to him. And then we got an email. It said, I get it now. I get what you were trying to say. And it hurt, but I'm going to show you that I can learn and get up to that level. And didn't hear anything for a while. We knew that he was working on various projects with customers and stuff, and actually they were being successful and happy customers. And then we heard he had taken a different job inside Oracle, and we're like, oh well, lost all that investment. We taught this guy how to use our software, taught him how to build things and so on. Trained someone else, whatever. Well, it turns out he didn't just leave. He went and built, architected Oracle's Elastic Charging Engine. And I stole this from a coherence marketing deck. So grains of salt and everything else, just assume it's all exaggerated and marketing lies and nonsense. But still, even if you water it down, it's like, holy cow. 3 billion SMS events processed per hour on 16 CPUs. That's more than the entire world's SMS traffic. Well, back a year ago or two when this slide was made. I'm sure it's more now. So here's a guy who's like, I got two choices, right? I could give up, or I could take it as a challenge. And I think, just watching a challenge like that sink in and settle into someone, and watching them bloom is just, it's a wonderful thing. So on that topic, how much time do I have? When am I supposed to finish? I thought this was 2 hours.
10 more minutes plus 5.
Okay, I'm gonna move quicker then. Dag burn it, you told me 2 hours. So on that topic, you always want to embrace criticism. Like if there's one thing you want to get good at, because it's the hardest thing to get good at, is be open to criticism. Because nobody likes to be criticized. Anybody here love to be criticized? One, couple sick people, yeah. But it is hard. It is really hard to take criticism. But always require a better option. This is one of the rules we always had in development. Like you can criticize anything. So we had a guy from the Ukraine, so kind of Russian/Ukraine speaking, and of course he used to obliterate the English language. So one of the sayings in English is "There's no sacred cows." So his was "There's no sacred cows." So we had no sacred cows. That was our motto. But basically what it meant is it doesn't matter whose idea it is. It's open for criticism. Just be willing. If you're going to come and criticize, you have to have a better plan. And it's a great rule of thumb because it forces people to do the homework, not just of sitting back and poking fun at something, but actually doing the work to come up with something better. I love this. I've been working on trying to figure out how to make this a rule, but does it support recursion? George, you're laughing. Did I talk to you about this one? I'm thinking of this as the new litmus test. In fact, think about it like this. Anyone know why A4 paper is special without looking at the screen? It recurses.
And it preserves the ratio.
Because A4 paper is actually half the size of A3. And A3 is half the size. Anyone know what the number 1618 is? 1.618? Oh my goodness. Golden ratio. Man, this guy's good. You should be speaking. What this means, let's think about it technically for a second. Everyone wants to write main. Do you know what I mean? Like everyone wants to be the one who writes the method main, right? I would say there should never, ever be a main longer than one line of code because I'm on stage and I get to make audacious claims that have no basis in fact. But what I mean by that is everything you write in terms of software, think of it in a conceptual manner. Everything should both be a container and a containee. In other words, you should both be composing and be composable. So when you think about good software that you've worked with, things that you like using and reusing, it's composable in nature. Talib, what do you think? Does this ring a bell? Like, you want to be able to compose things out of it. You want to be able to reuse it without rewriting it. Usually when we say reuse, we mean rewrite. You want to be able to reuse it. You want to be able to embed it in something else. And then if you do it well, your main ends up being one line of code. This doesn't just apply to software. This also applies to organizations. Organizations should be composable. Decision-making should be composable. In other words, if you are a manager and you're telling someone who works for you to do something that you would not tolerate being told, it sounds like the golden rule. So I wonder where the golden ratio came into this. If you think about it, all the golden rule is recursion, simple recursion. Like, can you describe, yeah, I'm not mathematical, so I'll go on to the next point. I love this one. Inelegant designs are almost always wrong. I put almost because I was afraid that someone could prove that there was some inelegant design sometime in the history of software that was actually right. But here's the thing. Complexity is the enemy. Our entire industry really has one purpose, which we fail horribly at, which is to manage complexity. Right? Think about the things you use online, why you like them. One reason you like them is because they actually let you get something done without having to remember 53 passwords and et cetera, very simple. So in software, anytime you encounter a design that's not simple, it's almost always wrong. What I was going to say about this, I was going to go into a big example with state machines and stuff, but I'll tell you a quick example because it's a lot easier and I don't have to go to the code editor, which makes me look like a moron. When we wrote Coherence, the first release of Coherence, we didn't actually ship. And that's because we had a bug in the software. And to fix it, the source code doubled in size, the number of lines. Not 2.0 times, but it was roughly twice the size after we fixed the bug. We looked at it and we said, something's wrong if the code has to double in size to fix that. We threw it away and we started again. So Coherence 2.0, we finished, about to ship, hit a bug. Guess what happened? Went to fix it. Source code, which was this time much larger than the 1.0, of course, had doubled in size by the time we fixed that bug. And the reason is because you can't code your way out of a design flaw. The only way to make software work is to design it to work. You design the edge conditions out on the whiteboard, not in the code. People and relationships are always a good investment. And sometimes the investment is you. What do I mean by this? Well, I don't get to code as much anymore. And if you can't tell by now, it makes me sad, very sad. But, I love coding. But I will tell you the one thing in my job that has replaced that joy that I would get from coding is actually when I see people in our organization, when I see them grow, whether it's grow technically, whether it's grow in terms of being a manager or build new capabilities into what they can do. And I would say that, even though I'm very unfortunate to have lost some really, really good people over the years, I never have ever regretted investing in them and watching them leave or whatever. So what I would say is this, if you ever get tired of writing software, the next thing you should be architecting, is organizations, is people, because the rewards there are just like that feeling, that joy in anyone read The Mythical Man Month? Yeah, quite a few. I love that book. That first chapter where he talks about castles out of air and the joy of creating. It's that same joy, that you see from the growth of people that you work with. On that topic, the bark is worse than the bite, and this is one of the hardest things I've ever had to learn, which is to say, you see a problem, you have to deal with it, and typically the hard problems are not technical problems. Anyone here think technical problems are harder than people problems? Because I find, like technical problems, I could deal with them all day, no problem. But people problems wear me out like a bad shoe. So I had an employee, actually a personal friend of mine from back in my school days, back in 1912. Anyway, great friend, great guy, a brilliant guy. And but the problem was, it just wasn't working. And we tried X, we tried Y, we tried Z, and like nothing that we tried would work. We'd put them on one project, there was conflict, and we couldn't figure, like, and I'd worked with this guy before, and he was brilliant. Like, he and I had built some really cool stuff at a previous company we had worked at, and it's like, I know he's brilliant. I know this should be working. And it was so frustrating not being able to find some combination that was going to work. And we knew where this train was heading, right? Like, there's the cliff. We're heading toward it. Like, oh no, maybe we can defer the inevitable, right? But it's called inevitable for a reason, right? It's because it's inevitable. Like, it's going to happen. And finally, I had a conversation with him. I said, look, and it tore me up. I didn't sleep for like a week before this. I was sick. I couldn't eat. And had to call with him. And I said, look, it's not working. And he said, I know it's not working. I've got to do something else. I'm thinking, and like, I just realized in that instant, like, he and I have both been struggling with the same thing. We were both scared of this imagination that didn't exist. Like, the bark was worse than the bite. Imagination was way worse than reality, which I think that brings me to my last one before we jump into my overtime. Always do what you know to be right. And this goes back to the recursive thing, right? Good information helps make good decisions, right? Whether it's technical information, whether it's organizational information, right? Honesty in a work environment is an absolutely critical part of, making something work. So Gil, you built like chips before, right? And they had half adders and crap like that. I'm going to pretend I know something about electrical engineering. Like, what if you put 2 and 2 and it came back as 5? What would you do? Like, how would the chip, it just couldn't work, right? You need the basic functionality of an organization to be, honest and straightforward and transparent, even when it hurts. So I wanted to give a brief example. I was interviewing a guy years ago, and he was really good because I was interviewing him for marketing. So he was like really slick, Like, I couldn't quite get through the veneer. So finally I said, what would you like your kids to think about what you do for a living, about your job? And it really put him off balance because, forced him to kind of dereference that pointer one more time, right? And look at it from a different angle. And then, coincidentally, a year or two after that, I was at work, and some of my employees were getting kicked out of their offices and being forced to go into cubes. And, I had warned the bureaucracy that this was going to happen, and it would be bad, and I'd lose these employees, and I said, you can't let this happen, and so on and so forth. And what do you know? It happened. And I wrote an email. I sat down, I wrote this email to some big important person, and I said, look, I told you not to let this happen. If I ask you for something, there's a legitimate business reason for it, and don't make me ask twice. And then I looked at my screen and I thought, yeah, if I send this email, I'm going to get fired. Shouldn't I? I mean, I was being an ass, which is my title. But then I asked myself, going back to that interview, I said, if I don't, what would I tell my kids I do for a living? I fight for people's offices and I lose and I give up. Right? So, long story short, didn't lose the offices. I made a few enemies. But never regretted it, you know. It hurts. I give you a story that had a good ending. I've had a few that are bad, usually my fault. But no matter what, yeah, so now there's a safe harbor statement. So look, I've only got 62 more slides, so if you can just... So my favorite parts coming from Java. Anyone pay attention to what's coming in Java? There's modularity coming. Have you heard of that? So modularity is basically a way to break all your applications by making sure that anything you use that was in a Sun package is now illegal, like MISC unsafe and all that. So value types are working around an evil design flaw in Java, which is basically this concept of identity. Every object has an identity. And the way that they do it is they trade off the concept of mutability and the concept of identity. And in exchange, they basically allow the equivalent of an object, an immutable object, to be completely inlined. How am I doing on time? 5? Oof. So, okay, I'll give you the tagline on this. Codes like a class, but it works like an int. So if you've used other languages, you've probably run into tuples. That's a great example. One of my favorite examples is I think we'll be able to implement IEEE 754 decimal with value types. I've actually implemented it on top of Java long, but needless to say, there's no language support for that. I just do the encoding and decoding. Let's see. Why are value types important? Well, they eliminate derefs, which is important on micro benchmarks. Smaller footprint, that's important. Big thing, though, is they can dramatically reduce the number of objects. And GC tends to be, Gil's going to argue with me because he always does on this point, but GC tends to be a function of the number of objects. If you don't know, Gil writes the VM, the Azul VM technology, which supposedly never pauses. So there's your pitch. So this is an example, by the way. Oh, did you see the link? I actually put a link. So you can look for value types on OpenJDK. This is an example from John Rose showing how point could be implemented. And it looks pretty much like a Java class. Note I made it bold here, the by value. That's kind of the only difference, really. And the fact that the compiler would know that it's immutable. So I'll give you an example of some work that we were doing in a similar vein. We did the same thing with, say, long values, which is a pretty obvious, easy one. And you can see 600 megs of RAM down to 40 megabytes, 7 seconds down to 2.5. So some pretty dramatic optimizations are possible. And this is all done in pure Java, so we weren't doing any unsafe or anything like that. Just some specific data structures. So this is the type of thing I would expect to see in Java 10. Now, there are strings, a great example of another thing you can do with value types. So a small string, for example, could be done entirely in line, so no separate char array, for example. They're still figuring out the details of how they could do this. But check this out. Single allocation, so that drops the number of objects in half for strings. Single cache line, because it's all, you know, the string and its contents are all in one cache line if it's small enough. And we'll talk about arrays 2.0 in a minute. But here's an example that we did with strings. It wasn't as good because it was actually slower because of the boxing and unboxing, if you will. But it was definitely smaller, 85% less memory. And when Java does it in Java, it should be much faster, actually. Right, George? Guaranteed. Arrays 2.0, this is one of my favorite things. I've been begging for this for years. See the previous presentation I linked to. So 64-bit array indexes. Is anyone really pissed off that they're limited to 2 billion items in an array? Like, you know, you have an array of phone numbers. Okay. Basically, what it does is it introduces a concept, almost like an interface. It says, this is what an array is, you know, get and set. And then some optional extensions there, too. Things for, like, split and all those, not fork join, but what am I thinking of? Help me out here. The MapReduce type things. Yes, there you go. And then there's a atomic under that I can't remember the name of. Let's see. Multi-dimensional arrays. So finally, you can replace your old Fortran code with Java. That'll be pretty cool. GC specialization. This is one that I haven't quite gotten the JVM team to commit on yet. So, by the way, all these things are obviously uncommitted thanks to the legal thing I put up. But if you think about it, Java GC is optimized for many small objects. So when I say small, like what's the biggest object you've ever had that's not an array? 100 fields? That's less than half a K, right? But if you have gigabytes of arrays, they're sitting in the same managed data structure, gigabytes and bytes, right? Do you notice something here? There's like bytes and gigabytes, and they're all kind of mixed in the same place. So this arrays 2.0 stuff can actually specialize the GC. I'm almost done, I swear. Let's see. And why is this so important? Well, all of our investment in GC at Oracle is going into G1, which is a compaction-based GC algorithm. And what it means is that if we have to copy those giant arrays, because all G1 does is copy, right? It's a compaction based on copying, if I understand correctly. So by having this specialization, we can basically just leave the arrays in place and then do the compaction on just those small objects. So dramatic optimizations. Is there at least someone in this room, Talib, who would be interested in this? Oh yeah. Not only that, a lot of the unsafe stuff goes away in Java 9, so we could sure use stuff like this, right, George? All right. And with that, I have come to the end of my presentation.